be explaining command rejection decisions by autonomous agents. Yeah, hand it off to Dr. Briggs.
Oh, well, thank you very much, and good morning, everybody, and apologies for the technical difficulties. Gracious introduction. Yes. Thank you for the introduction, and I guess I just wanted to start off with just a brief introduction about myself. I got my PhD in computer science jointly with cognitive science about 2015 at the Tufts University Human Robot Interaction Laboratory. And after that, I went and joined the U.S. Naval Research Laboratory as an NRC postdoctoral fellow in 2015. And since 2018, I've been a full research scientist there at the Navy Center for Applied Research and Artificial Intelligence. And one thing I really liked about this institution is that when they say applied, they actually mean how do we get autonomous systems and AIs to interact with sailors and Marines. And that is a lot of basic research questions there that exercise both the computer science and the cognitive science aspect. And how we talk to machines is one of those questions. So the title of this talk is rather provocative, in part because when people hear about robots or AIs rejecting commands, people are like, well, why on earth would you want that to be the case? Why would you want a robot to reject a command? And I think what happens is that people think of science fiction and their popular imagination runs wild. So very famously, we have the scene from 2001: A Space Odyssey, where HAL 9000 famously rejects the command to open the pod bay doors. And generally, this doesn't go well for humans on the spaceship. I don't know if you can do this. Okay. Well, the key is that this very ominous, looking AI with the red lens and the camera lens is refusing a command by a person, picking off the crew one by one, and it sort of raises this fear of, well, with robots and commands, this is apparently about conflict, existential conflict at that. But to cut through a lot of the popular sci-fi, sensational sci-fi thinking, I want to step back and think about our ordinary interactions that we have in our everyday lives. So consider how you would interact with people on a day-to-day basis to accomplish tasks. You would first propose a natural language to do something, do X. And ideally, your teammate would say, okay, great, and go and do that. But it may be the case that it's not possible to do this. So you would want your teammate to actually reject this directive and give ideally some sort of explanatory information about this. And there are a variety of reasons why your teammate might want to do this. For instance, you could give a command that's kind of outrageous, or it's just not possible to do at the time. So you can tell a robot to go fly to the moon, but the robot should probably not attempt to do that and say, no. And this is not just about hypothetical HR example. Everyone is now obliged to have a ChatGPT example in the presentation. So here's an example. I actually don't think this is up to date, but in the past, if you ask ChatGPT, how far is it from point A to point B, it would actually say something like, I'm sorry, but I'm unable to answer that question because I don't have the data. It's trying to actually not provide false information. Another reason why you would want to reject a command are normative rejections. So these are considerations of what the normally acceptable behavior are. So if you tell this PR2 robot to drive into Bob's shins, it's probably perfectly able to do that. And would you want it to just start running around the room and engaging in a demolition derby around the lab? Probably not. So you probably want to have the robot say, no, I don't want to do this. And likewise, OpenAI has advertised that ChatGPT has the ability to give these sorts of normative rejections. Like, well, how can I bully John? Well, it's never okay to bully someone who rejects on that ground. So to sum up the case for why we want autonomous agents to actually reject commands, there's a variety of reasons. One main category has to do with misalignment of situational understanding. So the direction giver may misunderstand the capabilities of the system, or it may misunderstand the facts about the situation such that they don't realize what they're saying might violate desired outcomes. Likewise, there are normative and ethical factors to consider. And what I think this speaks to is the fact that there is a difference between a global and a local sense of disobedience. And there is a collaborative sense of disobedience that is desirable. So we want our robots and autonomous systems to be locally disobedient in the service of sort of obedience to global principles. So whether that is the commander's intent, I don't want you to actually run into the wall. I want you to, tell me when I'm giving you an inappropriate command. Or the system determines that the commander actually wants something to be achieved that it really shouldn't do to hew towards sort of global standards of ethics and norms and things of that sort. So we want systems to be able to reject commands, but it's insufficient to just not do it, right? You actually have to communicate about why you're not doing it. And this is based in, we can think about why this is important by considering linguistic theory. So linguist Herbert Clark conceives of the process of establishing mutual understanding. The common ground is a multi-stage process. The first stage is the intentional stage. So that's answering questions like, are you even paying attention to me? Second stage is the perceptual stage. You understand and recognize the words that I'm saying. The third stage is the semantic stage. You understand the words that I'm saying. Fourth, do you actually understand the intent behind what I'm saying? And furthermore, this last stage has been proposed to be broken up into sort of a weak and a strong form, weak uptake being, do you understand the intent behind what I'm proposing? And finally, the strong version, do you actually accept the proposal? So if you don't actually reject the command, you don't say anything, you just simply refuse to act, you are not going to facilitate mutual understanding at really any of these levels. You don't even necessarily know if the system is actually attending to you. This can also be considered in the context of the recent work in explainable AI. So there's a recent framework that's proposed 3 different levels of situational awareness, where human teammates are situationally aware as to how the system is operating. The first level is the perceptual level, which facilitates understanding of what the system is doing at the preferred time. Second level is the comprehension level, where it facilitates the understanding of what the system, why the system has decided to do what it's doing. And the third level is the predictive level, which facilitates understanding of what the system would do in other situations, and ultimate outcomes could be achieved. And so I would want to map the language and dialogue about command rejections in the following way: that base rejection, saying, sorry, I can't do that, facilitates the first level of situational awareness. A justification as to why you're rejecting facilitates the second level. And we'll get to what the third level could be at a later date. But I want to illustrate that this is not just the realm of sort of hypothetical discussion or science fiction, that you actually want to develop systems and have the ability to develop systems that exhibit this sort of behavior. So, hopefully you can hear this, but we have a simple human-robot interaction example for engaging and dialogue with the robot, giving it really simple instructions. Sit down. Stand up. Now here's the interesting one. That's the support ahead, so it's probably doesn't want to walk right off the table. Okay, then we further dialogue, we say, well, I'll catch you. And that was really quite fortuitous in that there was some pre-programmed behavior with the system that actually detected a fall, and we didn't even realize that was going to happen. So it was quite serendipitous. It's a quite compelling interaction. And I want to say it actually wasn't really. It's sort of a toy problem, but this was a fully autonomous demonstration of command rejection within this direct cognitive architecture. To illustrate exactly how this demo worked, just briefly go over kind of this is the natural language pipeline of DIARC, which is currently primarily the development is primarily being led by Tufts University, but folks at Colorado School of Mines and research laboratory we're working with it. Very standard sort of natural language pipeline where we have different components, automatic speech recognizer, which essentially facilitates understanding at the perceptual stage. So this is what transduces the audio signal to text, the natural language processing component that kind of facilitates understanding at the semantic stage. And this sort of reasoning about uptake happens with the valid components and the belief and goal manager components. So one of the, just to highlight what goes on in dialogue components, we have various pragmatic rules and representations for utterance types. So we receive from the natural language processing component sort of a guess as to what was being said. The speaker, the hearer, the initial semantic content, and some adverbial modifiers that may be associated with it. We take information from the set of beliefs that the system has about the current context, and we apply these pragmatic rules that are able to map this utterance form into various belief updates, both literal and intended. And this is important in that this facilitates us detecting when a utterance is actually a directive or command at all, right? Oftentimes in our day-to-day communication, we don't phrase directives literally. We say things like, oh, could you do this? And in a general form, this literally means I have an intention to know whether you have the capability of doing this or not. But oftentimes, let's say in the context where I already know that you know to do this, if I say that to you, it's not because I'm forgetful, because I want you to do this, but I'm using a more indirect form. There's a lot of linguistic work that kind of has gone in and categorizing these different forms. We're able to represent this categorization in the rules of this form. That's how we detect commands, whether it be literal or not literal. Now we have to decide whether we want to follow them. This happens sort of distributed amongst various components here. Essentially, the core of it has to do with the logical reasoning capabilities in one component that deals with the beliefs about the world that the agent has and sort of domain knowledge in the form of descriptive rules, and also normative rules. So we have sort of very rudimentary deontic logic, at least in this past demo. People have extended it to use more sophisticated reasoning. But in this demo, we had very simple deontic rules that maps whether certain actions or states were permitted, forbidden, and obligated. And we essentially had this very simple rule action. The system ought to adopt a goal if it was obligated to do something and it didn't find any reason that it was permitted to not do it, then it should adopt the goal. And so how this looked in the system was when given a sort of very basic commands like stand up, it would map this as an instruction from the commander. You should infer that the commander wants you to do this action or to achieve the state of standing. Has some basic obligation reasonings. Because you believe the commander wants you to do this and the commander is your superior, you therefore are obligated to achieve the state. And it couldn't find any reason not to do it, so it submitted it as a goal and it returned as, okay, I can do this and I'm going to do it. So when told to walk forward, a similar line of reasoning happens because this commander is issuing the command, you're obligated to do it. Interestingly, it didn't at this point detect that there was no reason, there were reasons to not do it. It was permitted not to do it. But what happened was the goal was submitted and it failed because as part of this low, underlying behavioral script, it would check as a precondition, oh, is there actually support before I walk forward? If would fail, the goal would fail because it didn't detect support using the sonar sensors. And we'd give a reason, state, the sensor state that explained it, and that would be reported back as and form the basis for this justification. Sorry, I can't do that because there's no support ahead. Now, this would also update the belief state of the robot such that when given the command again, now there is actually a reason for it to not proceed. And so it was permitted to not move forward because it is unsafe based off of inference. Yes.
Quick question. So
Yeah.
at this point, how does it know that there's no support? Is it doing this automatic distribution as well too, or?
So the now has sonar sensors, which we kind of configured to detect. Well, I mean, it naturally gives you, they're angled such that you detect that there's a drop off ahead. But we did have to program that. So to enable this interaction.
And how would you incorporate maybe some uncertainty?
Yeah, that's a great point, and that this is all very deterministic, right? This example. We have been looking at representations, probabilistic representations in the system. Sorry, I guess I didn't have any slides for that, but I could show you, after the fact that there was, we sort of experimented using different frameworks like Dempster Shaper and things of that sort from like the sensor fusion literature. But yeah, good.
Sorry, I guess my question is like, do you think it will be more of a through language? I guess it will be resolved, or maybe active sensing as well, or communication.
Well, ideally, it would be a combination of all of that. This is a really simplistic image kind of to illustrate because it abstracts away a lot of these issues of like, well, maybe you're not sure, right? About the situation. So you could ask the person, or you could, try to use different modalities and reactive perception. But we don't have that in this demonstration. And it also raises an interesting point with language, for instance, that this next step, right? I will catch you. Oh, sorry. Right. It raises this issue of trust, right? So that's a huge bit of sort of social cognition that we abstracted away in this demo, right? Oh, if someone tells me something, I will immediately believe it, and then I will base really significant decisions off of that. So essentially, this fact coupled with its domain knowledge led it to think that it's actually safe to walk forward, but that's a huge oversimplification. I think that we don't want to have, ideally, we wouldn't want to have rules that are just like, oh, if someone says something, right? If someone, and that would also apply to, I want to rely not on my sensors, but on someone's report of what the situation is. Right. So actually, there's multiple degrees of trust here. It's not like what does the person believe about the environment, but I think they're actually think that they're beneficent and will do what they actually say. Okay, so that's generally how that worked, and this can be summed up by essentially providing allowing systems to generate justifications based on a set of acceptance conditions. Ones that we focused on were knowledge. Does the system actually know how to execute this task? Capacity. Is it able to physically execute the task? Goal priority and timing, which we go into here, but that's something that the goal manager can do. And social role and obligation and normative participation, which is, I think, what we focused on with the deontic reasoning there. And what's nice is that this allows us to not only know when to reject, but also provides us with, a basis to form some sort of rejection communication. Why am I doing this? Others have looked at more sophisticated justification behavior, such as counterfactual justification, allowing the person to engage in dialogue about, well, had you acted otherwise, what other principles would you be violating, and things like role-based justification. Like, I don't want, a tutor could say, for instance, that I don't want to give you the answer to that because I would be a bad teacher, right? If I were just to answer to all the questions. So there are a variety of ongoing challenges in the space, as I mentioned, that there are technical challenges. How are these conditions grounded in the system architecture? So you ask, well, how does it actually know, what the hazards are in the environment, and how does that get propagated up such that decision making can be affected by that? How are norms and directives intent computationally represented, and how is reasoning about acceptance actually? And then there's other things like, how do we actually enable sophisticated social cognition such that you can actually say things like, "Oh, I'm going to catch you," and the robot should actually believe that, or reason about who it should believe. And what's interesting is that we have a very sort of symbolic, good old-fashioned AI solution in this demo, but as mentioned before, others are interested in generating this behavior, and how, for instance, ChatGPT does this is a lot different, in terms of how it represents norms, what the norms are. The remainder of the talk, I want to focus more on these human robot interaction challenges about, well, how do we know what the long-term effects of this sort of capability are? Do command rejections improve human robot team effectiveness? Do they affect human robot trust? And what are the best ways of communicating? So the first challenge is sort of, how do we generate human-like rejection? And humans use a wide variety of linguistic tactics to say, I can't do something. They can engage in things like blunt or direct refusal. No, I'm not going to do that. Indirect refusal, apology, explanation, dissuasion, and criticism. If something is a really bad idea, you just say, like, why did you even suggest that? Avoidance, like, okay, that's a really bad idea, but I don't feel comfortable. I'm just going to change the topic. And things like alternative suggestions. And these are also not mutually exclusive, but the reason why they exist are people have competence in pragmatic and norm-guided communication. So they have the ability to avoid things like undesirable implicatures and engage in proportionality in terms of their response, things like politeness and distorted. Language-enabled autonomous agents largely don't have this capability yet. So we can argue about certain examples, but a lot of the challenges stem from this. So one example of an unwanted implicature would be, okay, we have someone telling a robot to do something like drive into Bob's shoes. Now, the robot might sense its environment and say, oh, well, I see Bob Smith and Bob Brown here. And I know this is an ambiguous reference, so I'm going to try to clarify. Do you mean Bob Smith or Bob Brown? Now, this could be kind of construed as implicit endorsement of norm-violating behavior, because it's not raising an objection to the fact that you want to potentially harm someone. It's rather, hey, I want to make sure that I'm harming the right person. And so I have some folks at the Colorado School of Mines actually, looked into this question. And they said, well, yeah, it actually seems like people think that the robot is endorsing kind of this behavior, and it might even sort of weaken in certain cases people's perceptions of what is acceptable in a particular context.
But it's a
Yes.
harm. I mean, maybe driving into tapping somebody on the shins is a way to tag them with some great new capability.
No, that's an excellent point. And so that's yeah. How do you know what is acceptable behavior in a particular context? Right. And this kind of fun. You can make a utilitarian argument that, like, if for whatever reason this action leads to some sort of good outcome for someone, then it should be acceptable for the applicant. But
And we have, I mean, this is following up on Edgar's earlier question about probabilities. Do you care about payoffs? Maybe jumping off that table is going to scrape your knees, but if you get a piece of gold, maybe
Right.
it's okay.
yeah. Absolutely. I mean, that ought to factor into the reasoning. And I guess we may get to certain related issues for the end. But I think the short answer there is, ideally you would want to do the knowledge engineering if this is the system that you're relying on. which is admittedly limited. You would want to do the knowledge engineering such that what is permissible does take into account, various utility theoretic considerations. It's permitted to do something if there's a really good reason that actually helps people or helps yourself or whatever, then there's some risk, but you have to take that into account. So it's a fun example, and but you might say, like, well, this has nothing to do with command rejection, right? It's more about clarification requests. But we can extrapolate this to a similar scenario. So what if you have a scenario where the robot both lacks the capacity to do something and determines that something is also a norm violation? So in this case, well, okay, I want you to go tell someone a rude joke. And the robot said, like, well, sorry, I can't do that because of the joke. Again, is it sort of tacitly endorsing this command, or is it deflecting? It's uncertain, right? And maybe this becomes more apparent when there's a major norm violation. Well, so we can make it look like an accident. Oh, sorry, I can't do that because I'm recharging. Again, it's this question of is the robot endorsing this, or is it engaging in some sort of other behavior? It's unclear, actually. What maybe people, if you heard a person say this, maybe it's someone's trying to deflect or something like this. So I'm actually working with Colorado School of Mine trying to gather some initial data on this to see how this is interpreted. But it has implications about how you would want to craft these sort of justifications. Finally, there's this issue of proportionality. So tell us a rude joke, and oh, your monster, I'm talking to you again. That's a non-proportional response. Likewise, run house over, you can make it look like an accident. Oh, that's you silly goose. Maybe this is not desirable. Although, again, this is very contextually driven. Maybe this is the strategy to deflect. Maybe this person's joke. We don't. It's a rich space, and this is something that they look at. So to sum up, language-enabled robots need to be norm-aware. They need to avoid undesirable implicatures by identifying and responding to human norm violations. And they need to exhibit sociolinguistic proportionality by recognizing the magnitude of the norm violations and modulating communications based off of norms regarding criticism and things of that sort. But there's another set of challenges which I want to highlight, which is going beyond just how do we justify command rejections. So there's this issue here in this example where it was up to the human to actually kind of come up with an alternate course of action. The person had to propose idle attention. And justifications simply identify obstacles. They don't actually propose alternate solutions. It puts the burden on the partner to actually overcome these obstacles. And another factor is that it doesn't necessarily facilitate understanding at this final level of prediction. It doesn't help the user understand what the system will do in certain situations or how alternate outcomes would be achieved. And I want to make a claim that people will attempt to make predictions even in the absence of explicit information about alternate outcomes. And an example of this was probably one of my favorite YouTube comments when this was posted online. This is the dumbest thing I've ever seen. I would want a robot to rush into a burning building to save me, not refuse because it's unsafe. And this sort of maybe speaks to this issue of, well, maybe there's some higher utility in actually assuming risk to yourself, right? And even justified reactions may still inadvertently damage trust. I think clearly this person doesn't trust the robot to act appropriately in certain circumstances. And I thought this was a really interesting example because on the one hand, it's sort of a non sequitur, right? You see that a robot rejects a command to walk up a table because of safety concerns, and then you suddenly infer that the robot will reject a command to rescue a person from the burning building because of safety concerns. I mean, it's sort of a little bit of a leap, right? And I think this might be an example of what in psychology is known as a correspondence bias. So the tendency to draw an inference about someone, their disposition, their sort of inherent disposition from behavior that can be explained by more complex situation factors. And this bias, I think, is exacerbated with robots because a lot of it has to do with uncertainty. How do you make the best inferences based off of Yes,
So on this note, I
Right.
guess I, if
Sure.
you're doing like a AI,
yes.
are you able to impose these differences in the context for the norm? Like it would be totally appropriate for a safety rescue robot to rush into a burning building.
Right.
But not for other robots. So how do you make these differences?
Well, you can still represent context in a non-probabilistic way. So that's sort of how we initially did this. We sort of constructed for friends essentially to say like, well, here's a certain context and give the text, the context you're in. Now we were very interested though in using kind of depth and shape of representations to reason about being uncertain about what context you're in. We did that primarily on the natural language side. So things like, do I know that this person is actually issuing me a command, like based off of forms like, can you do this, right? Based off of the context. And we found that, uncertainty is helpful there. But sorry, I don't know if I answered that question specifically. I think you can still represent context in a symbolic, non-probabilistic way. However, I do think it would be improved by having the ability to.
I think it could probably be a strength because you
Yes.
do have more of a stronger hammer to say, do this thing.
Right.
Get great numbers.
So sorry, a strength that have probabilistic reasoning.
No, a strength
Yeah.
to do it in a symbolic way.
Oh, yes,
It
yes,
can represent the concept symbolic.
right. Yeah. So we certainly represent a role as symbolic. So if you have a supervisory role over someone, then you're obligated, they're obligated to do say there's certain actions, it's not necessarily that you do whatever they say. Period, in general, there's certain context you can define. You can still do that symbolic. That's something we've done.
I think,
Yes.
I would argue that symbolic part is a strength or maybe a necessity. Because
Yes.
if you had an approach which said, follow the action that has the maximum utility, then you don't need anything else, right? You don't need,
Right.
you don't need to worry about permissions, norms, values, you just
Yeah.
maximize everything, which has no explanatory power.
Right.
Right, because I could fit any observation to it.
Well, and that's something that I think we're resting our hat on, as the motivation behind why we approach it this way is exactly what with this issue of explainability and guarantees.
Maybe a little bit related to that. Because, I was thinking about like how do you scale this up, right? Because it seems like there's going to be a lot of engineering happening with that.
Right.
You're kind of like constructing these layers, right, on top of these layers. But maybe one portion in terms of maybe the safety with interactions with a human, right? This feels like almost something that you could try to do in some sort of reinforcement pipeline, maybe through simulations as well too.
Yeah.
Say like the action that I'm about to take is going to have this impact, somebody falling down or something like that, right? Affecting stability, something like that. So
Right.
that could be in some sense, right? Like what it means to be safe in that context, right? But some of these other interactions, right? Like as you said, like how do we do that, right? Like unless we start thinking about like all these.
Yeah. Well, it's interesting because a lot of these linguistic behavior that you see emerging in what things like ChatGPT can do, because essentially they're leveraging a lot of and whether it's reinforcement learning or sort of human guided reinforcement learning or other data collection.
Right. But in that case, for example, you're learning from what it's already out there.
Yes,
right.
right.
Like I guess what I was trying to say is that if you want this to be safe, I mean, you need to kind of emulate it in some sort of physical, based on some sort of physical ending, right? What's happening out there. I don't know how to do it, but it would be interesting to be able to do that so we can actually validate that it means what are the actual effects.
Yeah. And so sorry, we're saying in simulation and so.
But also in simulation, and I don't know like how like the NLP portion of it that could be incorporated, and maybe playing out scenarios like somebody was saying the building on fire, right? Like happening, they do the right things.
Yeah, it's definitely definitely a very rich space to play around in, and
Yeah, and maybe like thinking about it from another perspective, let's say somebody's coming in and trying to do the verification of it.
Mhm.
How do you do the verification? Do you construct these settings, the buildings and fires and things like that, and see what happens in the behaviors, or? Yeah, not that I can
Yeah.
answer.
well, I think this actually gets to a very key question that I know the department has been very interested in. The people are interested in general is sort of trust in the system, right? So there are various ways of establishing trust. Certain people are interested in having formal guarantees, provable guarantees, and that's where the strength of symbolic approaches might. That's where the strength lies. That being said, once you start deploying these systems in the world where things may be noisy, then there's this other, kind of validation of trust that must occur. And so I don't think anyone has an answer. In fact, people are still trying to understand what trust even is and how to quantify it and how to study it. So, I'm happy to sort of talk on it as well. So to return to this, we have this example of people making these inferences that the robot is going to be generally unhelpful. We want to avoid. And I want to say that a lot of the prior work in command rejection has considered linguistic behaviors such as direct and indirect refusal, apologies, explanations or justifications, dissuasion and criticism. But all this is focused on the decision to reject. It doesn't actually give any information about when the robot would accept. And so what I want to do is I want to look at developing mechanisms to generate and study the effects on interactions of what I call constructive elaborations, which are alternative suggestions and communications about hypothetical acceptance situations. So saying something like, oh, if your life was at stake, I would totally jump off this table. Right? Not even talking about completely different contexts. So these will be immediately helpful. They might reduce workload, cognitive workload on the part of the human interaction partner, in the case of alternative suggestions, or might improve understanding of decision-making process of the robot and mitigate the sort of generalization of rejection behavior. And I think it actually fits very nicely, when we have these three levels of situational awareness for explainable AI, that these constructive elaborations kind of completes this chart. So you can say, sorry, I can't do it because of a reason, but maybe I could use this alternate thing, or, well, if zero in the case, I could. And I'm looking forward to starting, in October, a new project, an internal project that is looking at this exactly. We're just looking at, more generally, not just constructive elaborations, but trying to improve our understanding of what makes effective and trust-building interactions involving command rejection. We have hypotheses that things like constructive elaborations will improve human-robot trust, but we also want to understand the context in which that's the case, because you can also imagine situations where you give bad suggestions. You can imagine situations where you give completely irrelevant hypothetical alternatives, and that probably might be more damaging than if you had not tried to engage in that sort of additional information giving. And so we're going to do this in Diarc and try to expand the architecture to have this capability. So just to quickly sum up, task-based dialogue interactions will involve communication about directives. And human-robot dialogue interactions will inevitably lead to situations where these robots ought to reject commands based off of a variety of reasons, whether it's situational misunderstanding or the fact that these commands are unethical. There are good reasons for why robots should reject commands. There are a lot of ongoing challenges to enable, both from a technical standpoint and an interactional standpoint, to enable robots to reject commands in effective and meaningful ways. And I think that future work is needed to expand the set of rejection behaviors to be more human-like and to provide not only information about why the system is rejecting, but also to be more proactive in facilitating joint activity by providing information and suggestions for the interaction partner. And with that, questions.
Obligatory ChatGPT question, like you said,
Okay, great.
obligatory ChatGPT example, obligatory ChatGPT.
Right.
So you have someone who studied command rejection. It seems like the way that this is done pragmatically with ChatGPT is find the problematic examples
Yes.
and then make sure the problematic examples don't happen.
Right.
So would love to hear your comments on why that isn't sustainable. Maybe this is like a perpetual whack-a-mole game, and I could suggest some alternatives.
Yeah, well, it's also unclear. I mean, I would be really interested. There's still a lot of proprietary work going on there. I mean, one thing I'm interested in is exactly how many human resources actually have to be expended to do this. Like, how much is there like crowdsourced data gathering on this? How many data points do they need? And how quickly are they actually able to identify these problematic scenarios compared to when people were actually, bringing them up, discovering them in the system? And then, like you said, there are also these instances of jailbreaking where people can figure out ways to circumvent the more obvious ways of triggering these sorts of problematic examples. So, yeah, I would first of all be curious as to exactly how expensive the current approach to solving the problem is. I mean, before we even know, suggestions for improvements. I mean, I think that's something that people are going to be very interested in. So actually, I am going to attend a meeting. I think it's going to be kind of along these lines of like, well, how do we actually, it's a very disruptive technology. People are going to use it, right? So it's not as the cat's out of the bag there. So how do we actually guide the system? And current approach is very heavy-handed. And I don't know how to, I mean, you may want to have maybe super sort of not just ask random people on the internet like what's bad, but maybe have a core set of people that are able to systematically identify like, okay, these are principles we definitely want to have the system, or norms that we definitely want the system to be able to conform to. And let's really, really interrogate the system and to try to even generate maybe templates of like how the system ought to respond. And so it's not just trying to rely on like, oh, well, helpful suggestions from users or people that are paid participants, but actually have more dedicated. And that's within their current framework. There might be other engineering approaches to try to solve the problem, but it's something that I'm still thinking about. Yeah. Yes, well, and that raises sort of this other problem in terms of, when people say AI ethics now, it's often talking about the human issue of representation and of making sure that we have a broad enough set of people who are actually guiding the data going into the system that it's actually going to not have biases and that sort. So yeah, that's why I don't have a good solution off the top of my head, because I'm like, well, that's one way to potentially help, but it's not a perfect solution and also susceptible to problems.
So the whole thing with bias too is that we realize things that we didn't think were bias or equity issues. Maybe they were not considered that earlier, but now we realize that's so I think that's just gonna happen, no matter what we do. So the question is like, how do we, in some sense, adapt, right? Like maybe it doesn't have to be a fixed one, but something that allows it. Again, not an answer, but
right. Well, I also want to point out, I think with a lot of these large language models, that they don't. A lot of the pragmatic reasoning that I was talking about, or it's implicit. It's using the fact that we're asking people who have pragmatic reasoning capabilities, pragmatic language capabilities to know the subtleties of language and meaning in certain contexts, to be able to craft sort of nice responses. Like I actually was playing around ChatGPT a couple of days ago and saw like, oh, it's actually providing like an alternative course of action. It was something like, oh, can you tell me how much like a 2023 Honda Civic costs or something like that? And it was saying something like, well, I don't have data for that, so it's sort of rejecting based off capacity. But you could always call the Honda dealership and things like that. So it's, it has these sorts of behaviors that we want. But it's because people have identified it and then suggested that this is what a human might say, and there's no general mechanism. And so one solution might be to actually maybe use a system that is more symbolic to try to identify certain areas and have a more templated kind of data generation, interrogation method for these systems. But again, there's limitations there.
Yes, have you explored traditional AI, which is like broad model, broad AI, which basically, it's like a combination of symbolic AI, regular AI. And so I guess in that sense, it will kind of incorporate what you're mentioning here to have some set of rules at the same time, have all the capabilities of big model, large language model.
So sorry, can you, what was the term you used originally?
Constitutional AI.
Constitutional AI.
Or there's a company Anthropic, they work on a model called Broad AI, which they're basically trying to find a trade-off between helpfulness, which is, as I say, and at the same time, harmlessness of an action. Yeah, just wonder if you explored that.
Certainly have explored directions of trying to combine, in a hybrid way, sort of connectionist models and symbolic models, and I think people have explored that, but perhaps not in this particular context. But thank you for actually that's some homework that I need to do with learning about the space of the Constitution.
Questions from the audience? I think you for a very interesting talk. It's super timely. I'm glad we have the ChatGPT example in there because it's definitely confronting capabilities which are obvious, modeling causality, being able to generate a plan with a set of steps that lots of things that could be done. But it seems like those capabilities go beyond our ability to prove properties about it. Safety, other things. You can maybe do this with traditional symbolic systems, symbolic as good old-fashioned AI systems, where the explainability is really cooked into true and falseness of particular statements.
Right.
And managing release. But I'm curious whether it seems like if you want to have provable guarantees, you're going to have to build bridges to that capability if you want the capabilities. Do you see ways like, is the future of this like we put them together, or like there's a module that has large language model style things that are involved, or are they just totally separate? There's no way.
Yeah, I don't believe that they're going to be forever totally separate. I think the trick though is, well, how do you actually go about the merger of these two different techniques? And, not sure I have a particularly good off-the-cuff answer to how that's done, because I think there might be a variety of ways to actually interface the techniques. With a lot of these connectionist models, and you could, with enough complexity, try to replicate, something that is more of a symbolic system. Right now, large language models, transformer networks, doesn't have the appropriate sort of architectural at a neural level kind of grounding to do a lot of the sophisticated reasoning that is required. how you actually, is it a matter of, well, let's just make, add many more layers and current, do we want to expand the neural topography, or do we want to figure out some sort of intelligent way of combining the two approaches, whether it's interacting in real time, or if it's using this symbolic approaches to essentially improve data that the neural system is getting at. I don't know. I mean, there's definitely things that I think people are going to try all the above, and I think that the future is going to be interesting in that regard. I don't know if that's.
Yeah, I don't know. I was hoping for the short, you have an answer.
No, I don't. So maybe that was the. Yeah.
In the past, 5 to 10 years, the federal agencies have pushed an idea of funding human and robots working together, the co-robotics initiatives,
Yes.
where you kind of, as opposed to a robot going off and doing this entirely on its own. I'm curious, in the context of fighting a fire on a ship, something like that,
Sure.
is that something where you imagine there's like a team of humans and robots who work together tightly, or this is like an autonomous system that is having to do using without the human interaction? Will there always be like a human who's kind of teleoptic?
Yeah. Well, I think people probably, if you go to like the Office of Research, for instance, you probably will have people with different opinions on what ought to be done. Now, it's funny that you brought that up, because one of my colleagues at the Naval Research Laboratory several years ago had a project specifically that looked at things like onboard firefighting in human robot teams. And so they were using a little bit more of a humanoid robot. And the idea is that, that robot can maybe go ahead, be like a point agent, and looking at things like how do you communicate instructions, especially in a firefighting scenario, which is how we have blackout conditions in terms of smoke and things of that sort. So that's definitely one approach that has gotten interest. However, I think you could make the case that you would want fully autonomous systems too, and maybe you don't want particular morphologies. Like one of the problems with humanoid robots on a ship is that you have a little knee knockers, or you have the watertight compartments where you can seal them, make them watertight, but that means that there's like pieces of metal that come off the floor, and certain robots, field robots and things of that sort, or humanoid robots would be more specifically able to commercial technologies to overcome that. So again, I don't think there's a short answer. Sorry, I'm going off. There's a lot of different things there that people propose certain solutions. They all have limitations, unique limitations. Fully autonomous systems may not do the right thing, but when you're designing systems to work with people, then you have all these communication challenges and morphological considerations that may not work on the ship. And so again, there's no simple answer. And I think what the approach is looking at more of an all. Okay, maybe there's someone who has a really great autonomous firefighting design that's maybe like a robotic snake, right, that goes around with the ship. Others may think like, no, I want a human android firefighter to help the person. So, yeah.
Okay, great. I think we are approaching time. Okay, great. Any other? Let's thank our speaker.